So now we're going to do a test deposition of electron beam chromium. The first thing that we're going to do is we're going to turn on the high voltage power supply, the main circuit breaker. Next thing we're going to do is we're going to turn on our filament and check our chamber pressure. See, right now it's 5 times 10 to the minus 6 torr, which should be all right for doing a deposition. Next thing we're going to do is we're going to check that all of our interlocks are satisfied. So we're good here. Now we're going to turn on our high voltage. We'll see that the gauge here jumps up to 9 kilovolts, indicating that the step-start circuits on the power supply are working properly. If you turn this on and you see it still says 0, that indicates that you just need to turn that off and on again. We're also going to turn on the heating filament, and then we're going to press start. So this is just going to follow our recipe for the chromium deposition, and hopefully it doesn't exceed the pressure tolerance this time. So once the power reaches a value of about 13%, if you look into the viewport, you'll be able to visibly see the beam sweeping over the metal source. After about 15%, it will begin subliming, completely evaporating, which is what we have our soak power set to now. So it's going to sit at our soak power for 30 seconds. During this time, it's going to be outgassing any impurities on the metal source. Additionally, during this time, you may see that your gauge increases. So long as it doesn't increase past the 10 to the minus 4 threshold, it will still be able to run for the deposition. So now it's reached the pre-deposit point. It's going to lower the power to 13%. During this time, we can see that our pressure restabilizes. And then it's going to sit in the pre-deposit state for another 30 seconds before it enters the deposit state. So at 2 minutes, 30 seconds, you'll be able to hear the shutter open. You see, since it's on auto, it is now open during the deposit state. The power is going to raise until we reach the proper rate that we need to coat our sample at 1 angstroms per second. So see, now it's gotten to that point. It's now doing a feedback loop. And as soon as this hits 2 nanometers or 0.02 kiloangstroms, it's going to shut the shutter again. And again, now you can see the shutter is closed and our power has stopped. At this point, this sequence will try and go into the next step, which is a silver deposition. But since we don't need that, we're just going to press the abort button now. And it's going to be steady in this state. What we do now is we let the metal cool for about 10 minutes. This is to prevent any oxidation when we open the chamber. This is less of a concern with precious metals as they oxidize less easily. However, right now with chromium, if we open it up and it's very hot when it's exposed to atmosphere, you'll get a layer of oxide on the surface. So we're just going to let it cool, and then we'll come back to it. So additionally, when you are doing a 2-metal deposition, this is why we have the feed time programmed in. As of now, the carousel metal switchover is not automatic. So if you want to, during this time, say, switch to a silver source, you would have to manually, during the feed time, switch the carousel. The carousel will run and move to that source, and then it will start the second set. Additionally, before it goes on to the next set, it's currently programmed where you have to press start before the next process or the next film in the process will start. So if for any reason you walk away or forget about it, it won't continue on to the next step until you tell it to. So that's good. But other than that, you just have to make sure that you're changing over your metal sources And also, if you're doing a resistive evaporation instead, another thing to consider, that's going to be entirely manual for your second metal deposition.